Hello, this is Andrea Hendricks. The topic of this video is the unit circle. So what we're going to do in this video is talk about, first off, what is the equation of a unit circle. Then we're going to look at determining if a point lies on the unit circle. I'm going to call it UC for short. Then we're going to have to find a coordinate of a point on a unit circle. Then we're going to talk about the terminal points. And lastly, reference angles. So let's go back to talk about the equation of a unit circle. Before we can do the equation of the unit circle, let's recall the standard form of a circle. Do you recall that the equation of a circle is defined to be the points x, y that satisfy this equation, that x minus h squared plus y minus k squared is equal to r squared, where hk is the center of the circle and r is its radius. So the unit circle is just a specific case of this equation. The unit circle is defined to be the circle with center at the origin and radius 1. And so if we plug into this general form, we would have x minus 0 squared plus y minus 0 squared equals 1 squared, or more simply, just x squared plus y squared is equal to 1. So I have a copy of the unit circle drawn here on the coordinate system. For us to know that this is a unit circle, note that my center is at the origin, 0, 0. Notice that the center is not a point on the circle, right? It's just there to measure the points on the circle from the center, and they all need to be 1. So in other words, if I measure from the center to a point xy that is on the circle, that unit should just be 1. And so notice that if I go out my x-axis and y-axis, I get to 4 points on the circle. I get to the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And I can plug all of these into x squared plus y squared equals 1 and see that they do indeed lie on the unit circle. Now what about another point on the unit circle? Let's say if I have this point square root of 2 over 2, square root of 2 over 2. Oops. And I need to make that a negative because remember I'm in my quadrant 2 there. In fact, if I label the quadrants 1, 2, 3, and 4, all the things we know about the signs, because we're in the coordinate system, they still apply. So how can I check to see if this negative square root of 2 over 2, square root of 2 over 2 is on the unit circle? Well, I'd have to plug into the x squared plus y squared equals 1 to see if it satisfies that point. So let's check that. So if I have x squared plus y squared equals 1, and I know I have negative square root of 2 over 2 squared plus square root of 2 over 2 squared, does that indeed equal 1? Well, recall that when you square a fraction, you square the numerator and denominator. When we square a negative sign, we get a positive, and when we square a radical, it removes the radical. So the square root of 2 squared is just simply 2. 2 squared is 4, so we really have 2 fourths plus 2 fourths, which is 4 fourths or 1, so that checks. So in other words, the point square root or negative square root of 2 over 2 square root of 2 over 2 is on the unit circle. Now, what if I wanted to find the coordinates of a point, let's say where I had negative 1/2 as my x value, and I want to find out what is the y value for the point that's on the unit circle. So I know that that point is in quadrant 3, so that tells me that my y value needs to be negative. So whenever I plug into x squared plus y squared equals 1, I'm going to replace x with negative 1/2 squared plus y squared, I don't know, equals 1. So negative 1/2 squared is going to be a positive 1/4 plus y squared is equal to 1. So when I subtract 1/4 from both sides, I would get 1 minus 1/4, which is 4/4 minus 1/4, or 3/4. And then we have to use the square root property, which says that y would be plus or minus the square root of 3/4, or plus or minus the square root of 3 over the square root of 4, which is 2. Now, it can't be two values, right? It is just one of those values, and we talked about that already. Because we're in the third quadrant, the y value has to be negative. So my answer is going to be negative square root of 3 over 2. Okay? So if I'm given a point, to verify that it's on the unit circle, show that it satisfies that relationship of x squared plus y squared equals 1. If you're given one coordinate of a point on the unit circle, and you know where it lies in the coordinate system, then you're going to again plug one of those values into x squared plus y squared equals 1, solve for the other, and then use the fact about the signs to determine what the result needs to be. Okay? Okay, now let's talk about terminal points. When we talk about terminal points, we're going to think about a point T that moves from 1, 0 to another point x, y. And we want to think about what is the distance that they've moved, and what is that point x, y. Okay. So if we think a point beginning at 1, 0, and let's say that this point 1, 0, this point that is at 1, 0, moves, and we travel all the way around the unit circle. Well, because we know the circumference of a circle is 2 pi r, and in this case a unit circle has a radius 1, our circumference of that circle is just 2 pi. So when a point has begun at 1, 0 and traveled all the way around the circle, they've gone a distance of 2 pi. Okay? So when we think about what then is the coordinates of the terminal point T, so if we go from, if I think of T being all the way around the unit circle, in that case, T has gone 2 pi units, and the terminal point of 2 pi would be 1, 0. Okay, so if T is 2 pi, the point on the unit circle that it moves to is back at 1, 0. Well, what if the point only goes halfway around the unit circle? So if I start at 1, 0 and I move around and I stop when I get to this point over here. So there I've traveled just halfway around. Well, I didn't go a full 2 pi, but this case I went to half of that, which is just pi. So if T is pi units, then what is the terminal point? That is, a point on the unit circle that we move to would be the point -1, 0. Well, we can continue that. What if I'm at pi over 2? What would pi over 2 look like? Well, if pi is half of the unit circle, pi over 2 is 1/4 of the unit circle, right? So this distance here, so just think about the circumference. The full circumference is 2 pi, half of the circumference is pi, then 1/4 of it would be pi over 2. So if my terminal point moved from 1, 0 to this point 0, 1, my angle T is pi over 2. And we haven't really talked about them in terms of angles, but that's exactly what it is because I'm making a rotation around the circle. So this here would be pi over 2, and the point on the unit circle would be 0, 1. Well, if I go between pi and 2 pi, so if I stop here, I know my terminal point is 0, -1. Well, what is that angle? So let's think of it in terms of pi over 2. So if this is pi over 2, this is 2 pi over 2, this would be 3 pi over 2. So if my T value is 3 pi over 2, then the terminal point would be 0, -1. Now, there are some key values that you need to know for some of these values of T. And once we get into right triangles, I'll show you how we derive these values, and your book talks about it a little bit for just one of the particular values. But some other key values that you need to know are pi over 4, pi over 3, and pi over 6. Okay, so what would that mean? Let's just think about what is pi over 4. Well, if we know pi over 2 is halfway around half of the circle, if you will, right? Half of the circle is pi. Pi over 2 is half of that, so pi over 4 would be half of that, which would be to this point on the unit circle. And that terminal point is going to be square root of 2 over 2, square root of 2 over 2. And it's because the line that bisects this circle, the line y equals x bisects it at pi over 4, that is at the halfway point, and at that point x and y have to be the same. And so if you say x and y are the same, you can plug in place of y, let this be x, so you get x squared plus x squared equals 1. Solve that equation for x, and you find that you get the square root of 2 over 2, square root of 2 over 2 for the point. Okay, so that would be the terminal point for pi over 4. Okay, then pi over 3 and pi over 6, we're going to wait and talk about those when we get to right triangles. But you need to know what that refers to. So if I think about this upper half circle being pi units, if I divide it into thirds, I'm going to get the angle pi over 3. And so pi over 3 is more like right here. And I'm going to just tell you these values. It's if I can get it right, let me erase that. It's going to correspond to the point 1/2 square root of 3 over 2. So for pi over 3, the point is 1/2 square root of 3 over 2. And then what about pi over 6? Well, pi over 6 is cutting this upper half circle into sixths, and so we would actually get this here is pi over 6, and the point on the unit circle is going to be square root of 3 over 2 1/2. Okay. And let me back up for one other minute to talk about the angle that we initially started at. We said a full rotation around the circle is 2 pi. Well, if there's no rotation around the circle, that's just 0 units or 0 pi. And so this 0.10 corresponds to the value of t being 0 or 2 pi. But notice there's a pattern. Do you see the 1, 0? Then I have square root of 3 over 2, square root of 2 over 2, 1/2, and 0. So my x values are 1, square root of 3 over 2, square root of 2 over 2, 1/2, and 0. My y values are 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. So there is a very particular pattern there. Now, if I know these particular angles in the first quadrant, I can get values at the other quadrants because they're just mirror images. In other words, reflections across the x-axis or reflections across the y-axis. So the only thing that changes for those other points are going to be the signs, possibly. So what this means is that we can extend the unit circle values for t and talk about many values. Okay, so I have this coordinate system here drawn, and let me resize this for just a minute so I can get it all on the screen. Okay. So what we have here now is, this is a way to think about counting the unit circle. So you really do need to have the unit circle memorized. If I have this point 0, and then the half points are going to be pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, then 4 pi over 4, which is just pi, 6, okay, that was 4 pi over 4, then 5 pi over 4, then 6 pi over 4, which is 3 pi over 2, and then 7 pi over 4. And then we're back at 8 pi over 4, which is 2 pi. Now for the other separation, now if we count the rest of these divisions, we can count by pi over 6. So we'd have 1 pi over 6, 2 pi over 6, but that's just pi over 3, 3 pi over 6, which is pi over 2. So I'll write it there just for reference, but you don't really need to have that there. Then we have 4 pi over 6, which is 2 pi over 3, 5 pi over 6, this is 6 pi over 6, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6 would be the angle down below, so 9 pi over 6 and 10 pi over 6, which is really 5 pi over 3, then 11 pi over 6, and then 12 pi over 6, which is the 2 pi. Okay. So if you really know how to count by sixths and by fourths, you're going to get the unit circle. And then what we need to know is that the terminal point for those angles, or for those values of t, are going to be exactly what we learned in that first quadrant, but now just the signs are going to be different. So for instance, I know that this point was, I'm going to write it out here to the side, what was that, square root of 3 over 2, 1/2. Then we had square root of 2 over 2, square root of 2 over 2. Then we had 1/2, square root of 3 over 2. Then we had 0, 1. So now as we go around the circle, everything's going to be the same except for the sign. So now if I flip this point over across the y-axis, I'm going to get the same point that is a mirror image, but now it's in the second quadrant. So to represent that it's in the second quadrant, the x value is now negative. So these points here are going to be negative 1/2 square root of 3 over 2. Negative square root of 2 over 2, square root of 2 over 2. Negative square root of 3 over 2, 1/2. Negative 1, 0. And then when they go down to the third quadrant, notice now I'm doing another mirror image, but now it's across the x-axis. And so when I go across the x-axis, I have to also negate my y values. So these are going to be very similar, except that I'm going to have both the coordinates being negative. So negative square root of 3 over 2, negative 1/2. Negative square root of 2 over 2, negative square root of 2 over 2. Negative 1/2, negative square root of 3 over 2. And now when I go to the fourth quadrant, all the things are the same now, except that now my x values are going to be positive, but my y values are going to be negative, right? So I'm just thinking about flipping these over. And so I'd have square root of 3 over 2, negative 1/2. Square root of 2 over 2, negative square root of 2 over 2. One half, negative square root of 3 over 2, and then we already knew this one, 0, negative 1. Okay. So the interesting thing to note is that when the angle formed with the x-axis is the same, so like for instance, if this angle is the same as this angle, notice my terminal point is the same except for the signs. And so that's what we're talking about with a reference angle. If all you know is what's in the first quadrant, and then you know the reference angle is one of these values of pi over 6, pi over 4, pi over 3, then you can get what the terminal point is just by determining them where does it lie on the coordinate system, that is, what quadrant is it on. So when we talk about reference angles, they are the angle formed with the x-axis. Okay. And if the angle formed with the x-axis is t, then the terminal point is the same as the terminal point of t except for the signs. Okay.